Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for almost a decade, and I've achieved a 99th percentile score on the GMAT and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS think our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go. Welcome to Real GMAT Problems, episode 22. Doing real GMAT problems can help make test day a lot more familiar, so let's talk through a few of them together. The problems that we're going to go through are from the 11th edition of the Official Guide for GMAT Review, and you can web search them if you'd like to follow along visually. Just so you know, the 11th edition of the Official Guide is out of print, and that's partly why I'm going through questions from that book, because that way, if you purchase this year's Official Guide, there shouldn't be any overlap. The Official Guide contains retired problems that have appeared on past GMAT exams. So these are going to be very representative of the kinds of questions that you'll see on test day. I'll give you a chance to work through the solution on your own, and then I'll discuss my recommendations for what to learn from each question. I recommend pausing after I read through each problem and trying to solve it, or at the very least, visualize how you would solve it. You might not be able to execute all the steps in your head if you're on the go, but I recommend just doing your best. It's an excellent mental workout. If you are in a situation where you can physically write down what you would on test day, like if you're on a plane, for example, that's great. Here we go. This is problem number 74. There are 4 more women than men on Centerville's Board of Education. If there are 10 members on the board, how many are women? Again, there are 4 more women than men on Centerville's Board of Education. If there are 10 members on the board, how many are women? Option A is 3. Option B is 4. Option C is 6. Option D is 8. Option D is 7. And option E is 8. I highly recommend pausing here and working on the solution on your own for a moment, and then pick back up when you're ready. I'm going to just dive right in. This is a great problem to practice a couple basic algebra concepts, including something called substitution when you're dealing with multiple equations. It might have been a while since you thought about solving for variables or substituting while solving multiple equations, and that's completely fine. We've got a couple episodes linked below for you if you want to reskill with both of those concepts. Otherwise, I'm going to assume that you're familiar with those approaches and just jump right into a potential algebraic solution. Algebra is a good bet here because we've got a couple relationships that we can turn into equations. And once we have those equations, we can solve and we can get the answer that we want. Let's start with the first relationship we're given. There are 4 more women than men. If we set up some variables, let's say M equals the number of men and W equals the number of women, then we can express that relationship in a few ways. One would be W equals M plus 4. There are other versions of that equation that might make more sense to you, but ultimately we want there to be a number of men such that when we add 4 to that number, we get the number of women. So any equation that describes that relationship is going to work here. However you want to express relationships is fine. The point is we're able to make an equation that expresses that relationship mathematically. We're also given another relationship, but it's a bit less obvious. It says there are 10 members on the board, which is another way of saying that M plus W is equal to 10. Now, depending on your views, that might make sense to you and it might not. Just so you know, GMAC, the people who write the GMAT, they've moved away from problems like this that require you to identify people as specific genders. But these questions are about 20 years old in the 11th edition of the Official Guide. So you may see this kind of thing in old problems, even though they don't necessarily do this exact thing, this exact way on the exam anymore. However, they do similar things. So let's talk about that. The concept is relevant to current questions because a problem might say something like, there are only children and adults at a park. And you might be required to know that summing the number of children and the number of adults would equal the total number of people at the park. It's basically the same concept, or that's the concept they're trying to describe in this problem. So try to think about it in those terms, and these questions should get easier for you over time. Suspending current debate. Let's say we've got two equations here, and the first one is W equals M plus 4, and the second one is W plus M equals 10. Generally, when you have two unique equations and two unique variables, you'll be able to solve for each variable. And there's more on this in the Math Basics episode linked below if you're not sure what I'm talking about there. Like if this is your first contact with the GMAT, then I highly recommend some of those Math Basics episodes. It'll just help you understand everything that we're talking about here a little bit better. If you're already great with your Math Basics and everything I'm talking to you about here makes complete sense, then you probably don't need to go through that Math Basics series, or maybe just need to go through a little bit of it. So there are multiple options for solving these kinds of situations, but the most common is called substitution. So that's what I'm going to use here. And generally, I like to first isolate the variable I am not solving for. And that way, when I substitute, the variable I'm not solving for is going to disappear. Let me show you what I mean. This problem is asking me to solve for W. So I will first isolate M, the variable I am not trying to solve for. I want to solve for W, so I'm going to first isolate M. I can isolate M in either equation. So I'm just going to pick the first one, which is W equals M plus 4. So I'm just going to subtract 4 from both sides. And that gets me M equals W minus 4. Then I'm going to replace M in the second equation, which is W plus M equals 10, with W minus 4, because I know from solving the first equation that M is the same value as W minus 4. They're interchangeable values. If I replace M in the W plus M equals 10 equation with W minus 4, then I'm going to get W plus W minus 4 equals 10. And note that by isolating M and then substituting it with W minus 4, I now have an equation with just W in it, which is what I want to solve for. So that's why I like to first isolate the variable I am not solving for, then sub for that variable, which will make it disappear. And all we have to do to get our correct answer now is solve for W in the combined equation. So I've got W plus W minus 4 equals 10. I'm going to add the W's. That would be 2W minus 4 equals 10. Remember, when you're doing arithmetic, you, in general, want to go from left to right. So that's what I'm doing here. Let's add 4 to both sides to get 2 times W equals 14, and then let's divide both sides by 2 to get W equals 7. If it's been a while since you've simplified any equations, we've got an equations math basics episode linked for you below. You can reskill with that relatively quickly and be on your merry way with GMAT Quant. 7's our correct answer, which is also option D, as in delta. And I think this question's really not too bad if you're solid with your algebra and substitution basics. And that's why I like to go over some of these questions, because I think it's comforting to know that there are questions out there like this where it's like, if you just nail those basics, they're not necessarily trying to like trick you in some devious way. There are for sure questions that are much trickier and much more devious, but there are also these types of questions, and I think it's worth knowing about both. So even though I think if you're solid with your algebra basics and your substitution basics here, the question is not too bad, still 10% of people are missing this question, which I don't think is good. If we just buy into what I like to say at the beginning of every single episode, that business leadership is important, and this test, it can be a bottleneck for great business leadership, right? Like, do we want the best leaders in the world not getting into the best business school programs that might get them better odds of getting into positions of authority and influence just because they're not great standardized test takers? I don't know. I don't think that's the right thing to do. I understand why the test exists. It's important to have filters if we're going to be putting people in these very influential and powerful positions. But at the same time, why don't we give people the tools to get where they want to go, even if they are not great test takers? Maybe they're still going to be the best CEO of Unilever, or the best CEO of McDonald's, or the best marketing lead or team lead, or whatever your goals are for your MBA, the best roll-up people, if you're in the finance world. I mean, if we're going to have people doing this stuff, we might as well have the best in the world doing it, and the people who have shown they're capable of shaping things properly. This makes sense to me. So anyway, back to business. Any idea what the most popular wrong answer is on this question? I'll just remind you of the answer choices here. So A is 3, B is 4, C is 6, D is 7, and E is 8. If you're thinking the most popular wrong choice is A, you're right. Why might someone pick A and think the answer is 3? Well, that's the number of men on the board. So that's the answer that you pick if you do all the math properly but solve for the wrong thing, which is extraordinarily common and a very understandable mistake, but of course not one that we want to make if we're going to buy into some of the philosophy I was just describing. So what can we do to keep that from happening? I definitely feel like a broken record at this point, everybody, with this. If you've been following this show for some time, I've given tons of advice on this specific thing in this series, but the simplest, most widely applicable habit that I have seen help with this is just writing what the question asks 100% of the time. And I'm not going to beat that any more than I already have, beat that particular drum any more than I already have. So it's such a simple but powerful habit, and I hope you get as much mileage out of it as I have. But if you have your own takeaway for this question that might make more sense to you, given your situation or how you handled this question, that's totally fine. One final note on this question is that it's not a bad one to simply, quote unquote, guess and test using the given answers. If you have a moment to try that out for a sec, I'd highly recommend that. So just think about the problem again, think about the answers if you're able to write them down and visualize them, and see if you could get the right answer by just plugging them in and guessing and testing and seeing what happens. I'd recommend you pause if you want to give that a shot. Basically, you plug in one of the answers as the number of women, and then you see if that number, quote unquote, fits with the given constraints. It's kind of like trying a bunch of keys in a lock until one like clicks and works and opens the door. That's how I like to think about that. And it's actually a really useful strategy, especially on word problems. It doesn't have to be word problems, but I found it to be particularly useful on word problems that have relatively simple numbers in the answer choices. And some of the power here is like if you can't set up the algebra or you're struggling or you're unsure about how the algebra should look, then a lot of times plugging the answers and guessing and testing will still allow you to get the question right, even if you can't get that maybe quote unquote textbook approach. So it can make these really complex, difficult algebra questions like just a much more complex, difficult version of this question. It could make it a lot easier. Having said that, it might not be a great bet 100% of the time. Like the test isn't written expressly for you to be able to plug in the answers. And like the test writers aren't necessarily designing questions that way. At least I don't believe that they are. But it still works in a good number of situations. So I think it's very worth knowing and practicing the algebraic solution for sure. You'll want all those skills for future problems. Still, there's probably at least one question per quant section where guessing and testing with the answers would be really helpful, maybe even way more helpful than an algebra approach. So don't be afraid to do it. That's basically the message I want to give. If you're struggling to set up the problem another way, if you're struggling to set it up, don't be afraid to at least consider plugging in the answers. It can be a real lifesaver sometimes. But I'm not going to pretend that it's some silver bullet that's going to solve all your problems in the quant section without having to learn real math. Like it's not that. But give it a shot. And I have had clients over the years who do it on a significant number of problems every test, and they just get much better results for whatever reason. Like the algebra thing it doesn't click for them the same way that it clicks for a lot of people, and that's fine. So we've given some notes on writing what the question's asked, doing substitution with multiple equations, and guessing and testing with the answers. I think that's probably more than enough for that particular question. So I'd recommend you just take a step back and ask yourself, what do you want to remember from that, if anything? Even if what you want to remember is, I'm good with stuff like this, I'm cool, I don't need to do any more. And let's try another one when you're ready. This is problem number 75, and feel free to pause to make a note to self or write a takeaway for yourself there. Problem 75 says, Leona bought a 1-year, $10,000 certificate of deposit that paid interest at an annual rate of 8% compounded semi-annually. What was the total amount of interest paid on this certificate at maturity? Again, Leona bought a 1-year, $10,000 certificate of deposit that paid interest at an annual rate of 8% compounded semi-annually. What was the total amount of interest paid on this certificate at maturity? Option A is 10,464. Option B, 864. Option C, 816. Option D, 800. Option E, $480. Again, recommend pausing and working on this one on your own before we dive in. Here we go. Super valuable problem with a few critically important concepts that are very often misunderstood. So let's get those clarified, and then let's talk about why 19% of people are missing this question. First things first, think about what the question asks and think about the answer options. I'll read them again for you in a moment. Which answer is for sure not going to work here? Option A, 10,464. Option B, 864. Option C, 816. Option D, 800. Option E, 480. Option A is for sure not going to work. There is no way that the interest paid can exceed the principal in this kind of situation. 1 year at 8%, there is no way. But 4% of people are going for this answer, which I think suggests two things. Number one, most likely they didn't read or note the question carefully enough. And so they ended up just solving for the total value of the account at the end of the year, rather than what we are really being asked for, which is the interest only. We're not being asked for the principal plus interest. If you haven't built the habit of writing what's asked 100% of the time, that would be the critical next step to avoid missing questions like this if you were tempted by option A. So that's the first thing that I think 4% of people picking option A suggests. The second thing that I think it suggests is that people don't understand the difference between principal and interest, at least like a certain number of people. I'm not suggesting that all of you don't understand that. I'm sure many, many, many of you do, but at least some people probably do not understand that if they're picking A. So let's get that cleared up. Principal is the original amount that is invested. Interest is what's earned by the principal while it is invested. So if you need some flashcards or some notes to self there, definitely make those. And there's no need to be embarrassed here. We are all going to business school to improve our knowledge. Some of us are going to have a lot of knowledge going into that process. Some of us are going to have very little knowledge going into that process. I mean, if you've been a high school teacher for the last 10 years and now you want to go to business school to change the education system for the better or change your life for the better for your family and make a huge career shift, that's awesome. That's a huge reason why we're here. That's why I'm trying to support you. I think it's a beautiful thing when people improve themselves and become better professionals. It really matters. It really means a lot. I know it might seem just like this really self-centered thing, but we all have selfish. Well, let's not get into the philosophy here. Like basically, I believe we're doing the right thing here. Many of you have been in the finance world for a long time, and this is just like. This is like breathing to you. You know what I mean? Think about principal and interest. So it's all good. We're all here to learn and improve. So let's focus on that. So principal and interest are obviously related quantities, but they are separate quantities. That's really important. If I invest $1,000 at 5% simple annual interest for a year, I will earn $50 in interest. The principal is $1,000. The interest is $50. Again, related but separate. I need to know the principal in order to calculate the interest, but they aren't exactly the same thing. Generally, the total value of the investment at the end of the period will be the principal plus the interest, which in this case would be $1,050. If you can, you can see people getting mixed up between these two things under time pressure. So the vast majority of you will already be familiar with this language, but a few of you might not be, and that shouldn't be what stands between you and business leadership. So I hope that helps. Now, we've got A out of the way. Let's talk about the next stumbling block that it looks like people are facing here. 4% of people pick A, but 4% of people also pick D, which is $800. And that's wrong because that's simple annual interest, not compounding interest. This is really important and also much less understood by a way larger number of people in my experience. So let's make sure you're clear about this. Simple interest means it's calculated once per time period. Okay, so if it's simple annual interest, one time during that year, I'm going to be paid the interest rate. That's it. Again, simple equals calculated once per time period. You may want to make a flashcard or a note to solve for that, like send yourself an email or a text if you're on the go. If it's 8% simple annual interest on a $10,000 principal for 1 year, that would be $800 in interest. But that is definitely not what the question is asking about here. This question says annual rate of 8% compounded semi-annually. That is not simple interest because compounded means the interest is calculated more than once during the time period. As you might guess, compounded semi-annually means the interest is calculated twice in the 1 year period. But it's not as simple as 8% twice. And clearly a lot of people don't know that because 9%, more than double the other two wrong answers, are picking B, which is 10,000 times 0.08 plus 10,000 times 0.08 times 0.08, which is not how semi-annual compounding works on the GMAT. So let's get that cleared up. Compounded semi-annually means you split the annual interest in half. You add half the interest to the principal halfway through the year. Then you calculate the other half of the interest on that increased amount at the end of the year. And I go more in depth on that concepts in the Math Basic episode on percents. That'll be linked below. But I am going to talk about it a little bit here, just because I think a lot of people get mixed up. So there are two really important parts of the compounding interest piece. First, you want to split the annual rate in half. In this case, we have 8% annual interest, compounded semi-annually, which means twice per year. That means we're going to cut the annual rate into two calculations of 4% interest. So the first step is split the annual rate in half, two calculations of 4%. That's the first key. The second key is that you want to add the interest to the principal before the second calculation. This is part of the reason that compound interest is often more valuable than simple interest. Instead of just getting 8% interest on the principal, you get slightly more because you earn half of that interest on an increased amount. The second calculation of 4% will be on the previously increased by 4% amount. Let's do the math so you can see what I'm talking about. If we're going to split 8% in half, we'll start with 4% interest on the original $10,000. I've probably made this recommendation in the past, but I'll make it again here. It's usually a good idea to do these kinds of percent calculations as fractions because there's no calculator on the quant section. And that usually leads to fewer errors using fractions rather than decimals, but it is up to you. And if you're not making mistakes, I'm always going to judge your process based on your results. So I'm going to use fractions though. So I'll write out 10,000 over 1 times 4 over 100. And that allows me to cancel out a few zeros and make the math a bit simpler. Check out the Math Basics episode on fractions linked below if you're not sure what I mean by canceling. That would get us 100 over 1 times 4 over 1, which is going to be 400. So imagine that halfway through the year, we're paid the 4% interest on the original $10,000 investment, which would be $400, and that's added to the principal to have a total new principal for the second half of the year of $10,400. Then let's imagine at the end of the year that we get the next 4% of our total 8% annual interest. But instead of that 4% being calculated based just on the first 10,000, it's now calculated based on the 10,400 that we got as a result of being paid half the interest halfway through the year. Again, that's why compounding is often desirable. We're going to get a little bit more than $800 out of this. So let's perform that math. We'll start with 10,400 over 1 times 4 over 100. Again, let's cancel some zeros to get 104 over 1 times 4 over 1. Might need to do some long multiplication here. There's a Math Basics episode on that linked below. If you do that multiplication correctly, you should wind up with $416 as the second interest payment. So again, slightly more, $16 more in this case than we would have gotten with 8% simple. If we sum our two interest payments, $400 for the first payment and $416 for the second payment, we would get our total interest payment of $816, which is option C, as in Charlie, and that is the correct answer that we want here. So let's review a few key concepts so that this kind of thing is hopefully super easy and straightforward for you on test day. First, make sure you're answering the right question. Some questions will ask just for the interest payment, like this one does, while others may ask for the total amount in the account after the interest is paid, which would be principal plus interest. That's the first point. Second point, make sure you understand and memorize the difference between simple interest, which is calculated only once during the time period, and compound interest, which is calculated multiple times during the time period. Also, make sure you have a consistent process for avoiding calculation mistakes so you don't miss questions that you know how to do. I'd recommend one final note here. Generally, the three kinds of interest you'll see tested on the exam are number one, simple, number two, compounded semi-annually, and number three, compounded quarterly. I'm just briefly going to touch on compounded quarterly. You might be able to guess what that looks like based on the above discussion, or you might be familiar with this concept already, but for the sake of clarity and ease, when interest is compounded quarterly, you take the annual rate and you divide it by 4, and then you make the interest calculation 4 times, and you also make the interest payment 4 times during the time period, so you get some additional compounding. Let's do a quick demonstration of that, and then we'll move on. If you have an investment that pays 8% interest annually, but is compounded quarterly, you're going to split the 8% into 4 calculations of 2% each. I'm going to skip over the math here, but I do go through some examples of this in that percents episode I mentioned, which is linked below, but we will just kind of briefly go over it. So it'd be $10,000 times 102 over 100. That increases the original 10,000 by 2%. You can also do the 2% calculation and then just add that to the 10,000. It's the same thing mathematically. And then what we would do is we would take that increased amount and multiply by 102 over 100 again, which further increases it. Then we would multiply by 102 over 100 again, which further increases it. Then we do the 102 over 100 a fourth time, and that gets us our final amount. And so what we're doing is we're adding 2%, then adding 2% to that increased total again, then adding 2% of that increased total again 2 more times for a total of 4 additions of 2% to a number that's increasing as we add. And so each 2% is calculated on a slightly larger amount, and that's how we get more than 8% interest at the end. So the first payment would be 200, second payment would be 204, et cetera, et cetera, et cetera. I'll skip over the details. What's important is understanding the concept so you can execute it on test day. So that's some of the power of compounding as tested on the GMAT. Let us know if you have questions or feedback on any of this material by touching base with us at any time. You can reach us at the GMAT strategy on current social channels if you want to DM, or you can email us. Our email address is contact, C-O-N-T-A-C-T, at thegmatstrategy.com. In the meantime, if you want to make a quick note to yourself on either of these first 2 problems, feel free to do so before we move on to our final question together. All right, when you're ready, let's do a third one. This is problem number 76. Which of the following ratios is most nearly equal to the ratio 1 plus the square root of 5 to 2? Again, which of the following ratios is most nearly equal to the ratio 1 plus square root of 5, that quantity, 1 plus square root of 5, to 2? So the ratio is 1 plus root 5 to 2. Option A, 8 to 5. Option B, 6 to 5. Option C, 5 to 4. Option D, 2 to 1. Option E, 1 to 1. All right, here we are finally, after 70 or so problems together, starting to get into medium level questions with 28% of future business leaders of the world missing this one. So let's try to make this a bit easier. This is a good representation of how many medium level GMAT quant questions are constructed. It's not the most difficult medium level, and the medium level comprises a wide set of difficulty ranges. So things are going to get a lot harder in the medium level, but we're finally kind of crossing out a quote unquote easy just by the numbers. But yeah, it's a good example of how medium questions are constructed because it's basically just combining several concepts from several different areas that would by themselves be lower level questions. So in this case, we're combining ratios with square roots of and quote unquote non-integer results and estimation and just a few things that can kind of throw people off, as you can see with the numbers. I don't know that on surface value this one appears any more difficult than any of the other questions we've done together, but apparently by the numbers it is significantly more difficult for folks. So if you've been through the Math Basics program already, you might already be familiar with a lot of what's being tested here. That was my goal for you in that series. But there's also going to be a little bit of content to memorize for most of us, especially if you're just getting started. So You're probably familiar with the concept of ratios, but it might have been a long time since you thought about what the square root of 5 is. Maybe you never thought about it. So it's worth memorizing that for the GMAT, since there's no calculator available on the quant section, like I mentioned briefly a moment ago. But you do get a calculator for the data section, just to be clear. The square root of 5 isn't an integer. In fact, it is a very, very long decimal. So for most people, it's best to memorize it as approximately 2.2. If you punch root 5 into a calculator, you'll get slightly more than 2.2, but I think 2.2 is going to be the easiest estimation for most people. Notice that this question asks most nearly equal. And when GMAT questions use that language, they are inviting you to estimate. So for virtually all GMAT problems, memorizing that root 5 is approximately 2.2 should be more than accurate enough. Let me show you how that can help us out in this question. If we set up the ratio as a fraction, more on when and why this is a good idea in a moment, we would have 1 plus 2.2 on top and 2 on the bottom. That gets us 3.2 divided by 2, which, if you're solid with your decimal division skills, would give you 1.6. Now, 1.6 might not seem that helpful, but if we do a bit of long division on each answer, you'll see that it actually helps a lot. Let's start with option A. If we do long division of 8 by 5, we'll get 1.6 exactly. So that's a pretty darn good bet. I'll give you a bit of a shortcut for this and for double checking the other answers in a moment, but suffice to say B through E aren't as close, so we would pick A as an alpha, which is the correct answer. Now, a good shortcut for checking these answers is to memorize the decimal equivalents of all your thirds, fourths, fifths, eighths, ninths, and elevenths. Okay? So thirds, fourths, fifths, eighths, ninths, elevenths. To be clear, I mean know what 3/5 is as a decimal off the top of your head. Same with what's 3/8 as a decimal, what's 5/9 as a decimal, what's 6/11 as a decimal. Yeah, they come up enough that it's just worth it for most people, and this problem's a pretty good example. If you look at 8 over 5 in option A, and can immediately tell that the result will be 1 3/5, and you know that 3/5 is 0.6, you can save a good amount of time and energy here by avoiding long division. It's not that big of a deal to do 8 by 5 with long division, and it's not like it takes a ton of time, but it's still a nice win to have memorized these in advance. And as we get into more advanced questions, you'll see it can often help you recognize right answers or right solution paths, just knowing that those things are equivalent. So I can virtually guarantee you're going to experience the benefit of that long term. So that brings us to another important point, which is expressing the ratios as fractions. So just going to kind of press pause on the whole memorize your decimal equivalence thing for a sec. I promised that I would discuss when and why it's a good idea to express ratios as fractions, because that might not be natural for a lot of you. So for most people, the best time to express a ratio as a fraction is when you want to do math on the ratio, much like I did here. By expressing the ratio in the problem as a fraction, I was able to simplify it, boil it down, if you will, to 1.6, which is an easier number to compare to the answers, in my opinion. Now, there is a way to do it without decimals, which we'll explore in a moment, but I think it's useful to at least understand how the decimals in situations like this would operate. So let's just stick with that concept for one sec. I was also able to turn the ratios in the answers into decimals, and I just talked about how that might be helpful and useful. So that's the why of expressing ratios as fractions and then turning them into decimals. It can help you compare across different ratios that might seem similar, but are not the same and particularly close in value. For most people, distinguishing between 8 to 5 and 7 to 5 might be a big challenge when you're asked which one's closer to 37 to 27. We're not asked that in this question, but we could have been. That is totally fair game. If I said which is closer to the ratio 37 to 27, 8 to 5 or 7 to 5, that's going to be pretty tough for most people to make that estimation in their head without turning it into a fraction or also turning it into a decimal. But if you can express those ratios as decimals, it can make that comparison a lot easier. So again, I think it's worth understanding. Of course, you can avoid decimals here by simply expressing everything as a fraction from the beginning. For the sake of brevity, I'm not going to walk through all the math, but if that makes more sense to you, by all means, use that approach. It works very well. Even the fraction approach, though, furthers my point that it's usually best to express ratios as decimals or fractions if you want to operate on them. So if you want to do math on a ratio, such as reducing a fraction or comparing it to another value, or potentially inserting them into equations in different types of problems, don't be afraid to express the ratio as a fraction in that moment. It'll generally make the problem a lot easier to solve. So again, 28% of some of the brightest minds in business leadership of this generation are missing this question, which in my opinion is way, way too many. So hopefully now you've got the path forward as to how we can decrease that friction and help more of you get where you want to go faster. And you've got a few concepts that you can hopefully use on future questions like it as well. So I'm going to wrap there. Again, reach out anytime if you have questions. We're at the GMAT Strategy on current social channels. You can email us, contact, contact at thegmatstrategy.com. We love hearing from all of you. This is an incredible community of really, really awesome people doing really awesome things. And again, it's just exciting to hear from people who are leveling up. That's what's kept us on the team in the business for a long time, is being able to interact with folks like yourself. So we're always happy to hear from you and always happy to help. So if you want more tips and strategies for optimizing your performance on the exam, please head to our website, thegmatstrategy.com, which is linked in the description of this content. And I'd highly recommend checking out our free video on how you can reach your dream GMAT score in half the normal time. There's a lot of super valuable strategic advice in there that just doesn't translate well to the audio environment. So made that video for you. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies. You can do it. Talk to you all soon.